Identify the vertex of this quadratic equation in regular standard form. Now, the vertex is found by you taking the x value. The x value is negative b over 2a, right? Where you would be my a, you would be my b, and you would be my c. And by the way, if you're looking at negative b over 2a and thinking that that's 1/2 the quadratic formula, you're absolutely right. But that's neither here nor there. Once we find x, then we can find y by plugging that x value in. So let's do this first. Let's find out x. And by the way, the vertex is either the tippy top or the very bottom of a quadratic. That is a negative leading coefficient quadratic, which means it's going to look like that. So I'm finding a maximum value. Now you know. So the x value is going to be negative b, which is 18, over 2 times negative invisible 1. Okay, so negative 18 over negative 2 simplifies out to 9. So that's my x value. How do I find my y value? Well, just plug it in. So y is going to equal negative 9 squared plus 18 times 9 minus 75. Okay, so negative 81 plus 18 times 9 is going to be 162. And then minus 75. Okay, so negative 81 plus 162 is regular 81, and 81 minus 75 is going to be 6. So if our x value was 9 and our y value is 6, the vertex is going to live at the point 9, 6. Graph y equals x squared minus 2x minus 3. This is a quadratic. And a quadratic, when graphed, is going to be a parabola. Looks a little something like this. Now, it could be the upside down version, but I know it's the right side up version because the leading coefficient is positive. Now, this is what I know about parabolas when graphed. If I can find out what the vertex is, the left side and the right side can behave exactly the same. So that's how I'm going to handle this problem. I'm going to find my vertex, and I'm going to make a table based off of what these values are on maybe one side, and from the one side I can get the values from the other side pretty easily. So let's find the vertex. How do you find the vertex, you ask? Well, the vertex exists at x equals negative b over 2a, just like one chunk of the quadratic formula. So b would be u, a would be invisible 1. So the vertex would be negative 2 over 2 times invisible 1. So negative 2 over negative 2 is positive 1. So the center of my graph exists when x equals positive 1. So I'm going to make myself a nice little table. Okay, nice little table of x values. Okay, the center happens at 1, so I'll plug in 0, negative 1, negative 2. And plug in, I mean that in air quotes. And then I'll plug in 2, 3, and 4. I don't mean that in air quotes. All right, so at 1 is the center of everything. So let's see what happens when we plug in y, or 1 for y. So, just quick math, it'll be y will equal 1 squared minus 2 times 1 minus 3. So that'll be 1 minus 2 minus 3. And 1 minus 2 is negative 1 minus 3 is negative 4. Okay, so I have the point 0, negative 4. I'm sorry, 1, negative 4, 1, negative 4. That's going to be my minimum value where my vertex exists. Let's try it again. Let's plug in 2, so I get 2 squared, which is 4, minus 2 times 2, which is also 4. So 4 minus 4 goes away. Minus 3 is negative 3. So 2 is going to be negative 3. Now let's use a little bit of common sense. Okay, if my picture is going to look like this, and I bottom out here, and this guy is supposed to mirror the other guy, I know I'm going to have a point right there. Okay, so I know you're also, and if you're like, I don't believe you, all right, well, plug in 0. If you plug in 0, you get 0 minus 3, so it is negative 3, so don't overthink it. I'm not a liar. I'm not a liar, all right? Let's try 3, see what happens when we plug in 3. I get 3 squared, minus 2 times 3 minus 3. So 9 minus 6 is 3. 3 minus 3 is 0. So we get 0 whenever we have 3. So when the x value is 3, the y value is 0, which means when the x value is negative 1, the y value is also 0, like so. Okay? What color did we use it? Red? So let's do the same thing for 4. If that fits on the graph, it should fit on the graph. Y equals maybe 4 squared minus 2 times 4 minus 3. So I got 16 minus 8 minus 3 is 5. That will fit on the graph. So when I plug in 4, I get 5, which means when I plug in negative 2, I also get 5. This is the part where I'm not going to get a pretty looking picture here. I'm going to try to graph this best I can. Okay, again, parabola, a nice smooth looking curve like so. Bang. I'll give myself some credit. That's not too bad, except that it ended poorly there. But there you go. That's how you graph it. So you can plug in whatever values you want and see what happens, or you can use common sense, find the vertex. That'll get you your center, and once you get your center, it'll be easier to graph the rest. Graph y equals negative x squared minus 6x minus 10. Well, what I could do is I could just pick some random x values and plug those in and see what I get, or I could use a little bit of common sense when I graph this. First things first, my leading coefficient is negative invisible 1. So I know that not only is this a parabola, this is a parabola that opens downward like so. If I find my vertex, I know that whatever point I get here, I'll get the same point over here. So what I'm going to want to do is find the vertex. That'll allow me to find the center of everything. And then I can start plugging in numbers over here. And once I figure out what those are, I get the same guys over there. So what is my vertex? Well, the vertex exists at y equals negative b over 2a, right? So you would be my a, you would be my b. So x equals negative 6 over 2 times negative 1. All right, so 3 negatives is going to make the whole thing negative. 6 over 2 is going to be negative 3. So the center of my graph is going to exist when x equals negative 3. Negative 3, not positive 3, negative 3. So let's make a table, knowing very well that my center is going to exist at negative 3, so x values, y values, negative 3 right here. So I'll plug in negative 2, negative 1, and 0. I'll plug in negative, well, I won't plug those in because I know it's going to happen already. But once I plug in negative 3, that's going to get me my tippy top. Okay, and from there I can get more points, knowing very well that the left and the right mirror each other. So let's plug in negative 3 because that is my center. Okay, if I plug in negative 3, I'm going to get negative 3 squared minus 6 times negative 3 minus 10. So mental math, and it's not pretty mental math, but it's still going to be mental math. Negative 3 squared is 9. Negative 9 plus 18 is 9. 9 minus 10 is negative 1. So when I plug in negative 3, I get negative 1. When I plug in negative 3, I get negative 1, and that's going to be my tippy top. So at no point will this cross the x-axis. So I might run out of points pretty quickly. Maybe, maybe not. I guess we'll find out. But if I plug in negative 2, I'll get negative 2 squared minus 6 times negative 2 minus 10. Okay, negative 2 squared is going to be 4. So negative 4 plus 12. Negative 4 plus 12 is 6. No, negative 4 plus 12 is 8. And 8 minus 10 is negative 2. So when I plug in negative 2, I get negative 2. Which means when I plug in negative, since this is the very tippy top, this is going to go like this. So if I plug in negative 4, I also get negative 2. So we're not going to overthink it. We're just going to put our dots over there. Alright. Alright. See what happens when we plug in negative 1. Negative 1 squared minus 6 times negative 1 minus 10. Negative 1 squared is 1. Negative 1 plus 6 is 5. 5 minus 10 is negative 5. Okay, so when I plug in negative 1, I get negative 5. When I plug in -1, I get -5, which means when I plug in -5, I also get -5. All right, now the last guy is going to be friendly, but I have a feeling it'll fall off the graph. In fact, it will. If I were to plug in 0, I would get 0 minus 10, which doesn't exist on the graph. So I'm not even going to bother. You would be -10. You would be -10. It's not going to show up on the graph anyway. So when I graph this, it's going to be a nice curve. Try to draw it out as best as you can. I'm awful at drawing these, but that's what this is going to look like. So there you have it. All right. So there's my quadratic, there's my parabola. Fun, 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 fun. Identify the maximum / minimum. Well, first things first, let's see what we have here. We have a quadratic where the leading coefficient is negative invisible 1, which means it's going to look like an upside down parabola. So what I'm going to get here is I'm going to get a maximum. Now that point is also called a vertex. The vertex exists when x equals -b over 2a. So since my leading coefficient is negative invisible 1, you're going to be my a, and my b is going to be that 8 right there. So x equals -8 over 2 times -1. So -8 over -2 is going to equal 4. So my maximum is going to exist when x equals 4. Let's find out what the f of x value is by plugging in 4. So f of 4 is going to equal -4 squared plus 8 times 4 minus 20. Okay, -4 squared is -16. 8 times 4 is 32 minus 20. -16 plus 32 is 16. 16 minus 20 is -4. So when my x was 4, my y was -4, and that's going to be a maximum value. And that's how you do it. Identify the vertex, the axis of symmetry, and the y-intercept. Well, let's actually do this. Let's find out the axis of symmetry, because when we find the vertex, we actually find the axis of symmetry. Now, the vertex is found by taking x equals -b over 2a and then plugging that value in to find your y value. Well, x equals -b over 2a also happens to be the axis of symmetry. So the axis of symmetry is going to be the vertical line x equals -b over 2a. Just for a nice visual, really quick before I even get started, that is a quadratic. The leading coefficient is positive, so generally speaking, it's going to look like this. So the vertex is going to be some minimum value. The axis of symmetry is going to be some vertical line that goes through the vertex. And then the y-intercept is going to be easy to find when we get there. Now, x equals -b over 2a means you're going to be my a, and b is going to be -54. So x equals -54 over 2 times 3. So x equals -54 over 6, which is going to be double negative x equals 9. So that is my axis of symmetry, the vertical line x equals 9. Now, since x equals 9 is going to be the x value that goes through the vertex, that'll allow me to find the rest of my vertex. So my vertex exists at the point where x equals 9. So I'm going to find out what f of 9 is. Ugh, it's going to be some ugly numbers, but that's all right. F of 9 has me replacing x with 9, so 3 times 9 squared minus 54 times 9 plus 241. Okay, so that is going to be 3 times 81 minus 486 plus 241. 3 times 81 is 243 minus 486 plus 241. Let's do this. Since I don't have a calculator handy, why don't I add the two positives together and hope for the best? When I add the two positives together, that gives me 484 minus 486, much more pleasant to deal with. That's going to get me negative 4. No, that's going to get me negative 2. Ooh. Whew. 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 All right. So when I plugged in 9, I got negative 2, which means my vertex is going to be the point 9, negative 2. Now, my y-intercept exists when the x values are 0. So this is wonderful. So when the x values are 0, you have 3 times 0 squared minus 54 times 0 plus 241. These go away, and you're left with a y-intercept of 241. Now, generally speaking, right, your y-intercept exists at the constant number here. So, like, I didn't have to do any math, but I did anyway just for funsies, and it was fun, wasn't it? So much. Write the vertex form of the parabola y equals x squared minus 12x plus 46. This guy is called standard form. Standard form is y equals ax squared minus, or plus rather, bx plus c. Vertex form is y equals a times the quantity x minus h squared plus k. These a's are the same a's. H and k is going to be your vertex. So this is what I have to do. I have to take this information here, find my vertex. Once I find my vertex, I'll label it HK. I already know that A is invisible 1. I put it all together in that formula right there, and that's going to be my guy. So, how do we find the vertex? Well, we find the vertex by first finding the x as a symmetry, which is x equals negative b over 2a. Okay, so again, A is invisible 1. We know that. B is negative 12. So finding my vertex so far is me doing negative 12 over 2 times 1. So that would be double negative, which is positive. 12 over 2 is 6. So my vertex has an h value of 6. In order to find the k value, which is my y, I'm going to replace 6 or x with 6 and solve for that. So the y value of my vertex is going to be 6 squared minus 12 times 6 plus 46. You become 36 minus 72 plus 46. Let's add the two positives together because that'll be easier in my little brain. There's no way. Is that 72? No, it's 82. That would have been so nice. That's all right. I'll take 82. 82 minus 72 is 10. Which means my vertex is 6, 10. The area code in which I live. So vertex is 610. So I'm going to label you H and K. I already know that my A is invisible 1. So going by the letter of the law and really writing things out, we would say that y equals A, which is 1, times the quantity x minus h, which is 6, squared plus 10. And then someone will be like, you silly goose, you don't need that 1. So final answer is x minus 6 squared plus 10 is going to be the vertex form of that parabola right there. Right, the vertex form of the parabola. That is a parabola. Doesn't look like one, but it sure is. Vertex form, by the way, is y equals a times the quantity x minus h squared plus k. Okay, now what h and k are is the vertex. So the vertex is the point hk. Now a is the same a that appears when you're looking at a parabola in standard form. So here's the parabola in standard form. If you're looking at this and looking at that and saying, they don't look the same, oh, you're right. So what we need to do is get y all by itself. Now, the nice thing is y, I guess probably what I'm going to want to do is subtract 6x squared from both sides, subtract 12x from both sides, subtract 13 from both sides, and we just have negatives everywhere. Negatives everywhere, but not a drop to drink. Now, that leaves us with y minus negative 6x squared minus 12x minus 13. Now the a in here is the same a here, so that gives me one thing. The other thing I don't have is the vertex. Well, I find out the vertex by first figuring out the axis of symmetry, which means I'm going to need a b, and the axis of symmetry is found by doing x equals negative b over 2a. Once I find that x value, I'll plug that in here to find the y value. So x is going to equal negative 12 over 2 times negative 6, which is going to be negative 12 over 6. I'm sorry, negative 12 over negative 12. Ugh. Right? I can handle that. That's just 1. So x is negative 1. So the x value is going to be negative 1. So this is the x value in my vertex. How do I find the y value in my vertex? Well, I just plug it in. So the y value in my vertex is going to be y equals negative 6 times negative 1 squared minus 12 times negative 1 minus 13. Negative 1 squared is 1. Negative 6 times 1 is negative 6. Negative 12 times negative 1 is plus 12. And then minus 13 is just lingering like that song from the 90s. Negative 6 plus 12 is 6. 6 minus 13 is negative 7. So that gives me a vertex of negative 1, negative 7. So I'm going to label you H. I'm going to label you K. Ooh, UK, United Kingdom. I'm going to reiterate the fact that A is negative 6, and I just plug stuff into that red formula that I have up there. The vertex form is y equals A, which is negative 6, times x minus h, which is negative 1, so I'll clean that up in a minute, squared plus negative 7. I'll clean that up in a minute. So my final answer, y equals negative 6, x double negative, plus 1 squared minus negative minus 7. And that is that. Graph f of x equals negative 3, x minus 2 in parentheses squared minus 4. This, boys and girls, is a parabola in vertex form. All right? Now, vertex form gives me a couple things. Okay, first things first. What I know is vertex form looks like this. A times x minus h squared plus k, where my vertex is hk. So why don't I identify the fact that if I have negative h is negative 2, positive h is positive 2, and if k is negative 4, then k is negative 4. And so my vertex is 2, negative 4. What I also know is that if I were to plug in some points to the left or to the right, because I'm not going to have a lot of space here, I'm going to be honest. That negative 3 means it opens downward. When a is negative, it opens downward. So I might have the opportunity to plug in 1 or 2 points. So what I know is, since you are my middle, if I can find out what happens at 3, that tells me exactly what happens at 1. Because whatever happens to the right of 2 is going to happen directly to the left of 2. And if I can find out what happens at 4, then I know what happens at 0. Okay, so why don't I do that? Why don't I find out what happens at 3? Why don't I find out what f of 3 is? Okay, so f of 3 is going to be negative 3 times 3 minus 2 squared minus 4. So negative 3 times 1 squared minus 4. 1 squared is 1. Negative 3 times 1 is negative 3, and negative 3 minus 4 is negative 7. So I'm not going to have any more space to make more points after I do this. If I plug in a regular 3 and get negative 7, that puts a dot there. That means when I go to 1, I'm also going to get negative 7. And this makes sense. The larger the digit in front, or that a is, the skinnier my graph is going to be. So I don't have a lot of space for this. So I'm drawing this out to the best of my ability. Please comment how good that looks. But that's it. That's my parabola. There's not much more I can do with it. It's not the prettiest thing in the world, but that's the answer. Graph y is less than negative 2x squared. In order to graph this, we need to have a good idea of what negative 2x squared looks like. So let's, pick a couple x values, get a couple y values, and see what happens. Now, since there's no adding or subtracting or anything like that, and it's just x squared, I know my vertex is going to be smack dab right there at the origin. I'm not adding, I'm not subtracting, smack dab at the origin. So why don't I pick 0? Whatever 1 is, negative 1 is going to behave the same way. Whatever 2 is, negative 2 is going to behave the same way. And whatever 3 is, negative 3 is going to behave the same way. All right, when I plug in 0, I get negative 2 times 0, which is 0. Easy peasy, I knew that would happen. When I plug in 1, and again, since this is a parabola, and the left side and the right side are going to behave the same way, whatever I get for 1, negative 1 is going to be the same. So negative 2 times 1 squared is going to be negative 2 times 1, which is negative 2. So 1 is negative 2, negative 1 is negative 2. Let's do the same thing for 2. Negative 2 times 2 squared is the same as negative 2 times 4, which is the same as negative 8. Now we should know now that if you are negative 8, you are a negative 8. I am not going to bother plugging in 3 because it's not going to work. Number's too big, so I'm not going to bother. All right, not going to bother. Now, that is what the graph is going to be shaped like. This is an inequality, which means I have to remember two specific things. Thing number one, and it's all based on the fact that that's a less than symbol. Thing number one that I have to remember is since that's a less than and not less than or equal to, I'm going to draw out a dashed line. So my parabola is going to be this dashed curve like this. I'm doing the best I can, doing the best I can, doing the best I can. Okay? That's one thing that I have to remember. Thing two that I have to remember is since this is less than, it's going to be shaded underneath, which is going to look like this. This is what under the graph looks like, and it appears like it's inside. But this is a shaded region. What this means is everything in this yellow region, so 0, negative 5, 1, negative 8, anything in this shaded region is a possible solution to this inequality. Now, does the graph or does the dashed line count? No. So I'm not allowed to be like, well, let's plug in 1, negative 2 and see if that works. It won't. But if I plug in 1, negative 4, it'll work just fine because it falls in the shaded region. So that's what an inequality of a parabola looks like and what it means. Graph y is greater than negative 2x squared plus 16x minus 34. This is an inequality, which means I have to understand two things. But before I can even consider that, I don't even know what this guy looks like. So why don't I graph this out? And in order to help me graph it out, why don't I find out where the vertex is so that I know where the middle lies? So the vertex is negative b over 2a. So u would be my a, u would be my b. So if my x is negative b over 2a, that's negative 16 over 2 times negative 2, which is going to be negative 16 over negative 4, which is going to be 4. So all the action begins at 4. This is a negative leading coefficient, so this is going to open downward. So this guy is going to look like this, and if you're like, whoa, 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 what's wrong with your graph? Give me a minute. It's going to look like this. And whatever happens just to the right of it is going to behave exactly just to the left of it, and all the action again starts at 4. So why don't I make a little table of x values, right? 4 is going to be in the middle. Let me plug in 4, let me plug in 5, let me plug in 6. Whatever I get for 5, 3 is going to behave the same. Whatever I get for 6, 2 is going to behave the same, because whatever I get for 5, that happens mirror image, that happens mirror image. All right, so let's plug in 4. My vertex. When I plug in 4, which is my vertex, I'm going to get negative 2 times 4 squared plus 16 times 4 minus 34. Okay, that's going to be negative 2 times 16 plus 64 minus 34. Negative 2 times 16 is negative 32. Negative 32 plus 64 is 32, and 32 minus 34 is negative 2. I had to do a little bit of hand waving. I ran out of space there. So 4, negative 2. There's the dot. Let's plug in 5, see what happens. And when I plug in 5, 3 is going to give me the same thing. So negative 2 times 5 squared plus 16 times 5 minus 34. Okay, 5 squared is 25. Negative 2 times that is negative 50. Just trying to do a little bit more. 16 times 5 is, what is that, 80? Minus 34. So negative 50 plus 80 is 30. 30 minus 34 is negative 4. So if 5 is negative 4, then 3 is negative 4. These are y values. I don't know why I didn't do that. 3 is negative 4. Okay, let's do it again for 6. Negative 2 times 6 squared plus 16 times 6 minus 34. 6 squared is 36. Negative 2 times 36 is negative 72. 16 times 6 is 96. Then you have minus 34. 96 minus 72 is 16. No, it's 26. No, actually it's 24. I don't know what I was thinking. And 24 minus 34 is negative 10. So since 6 is negative 10, 6 is negative 10, that would mean 2 is also negative 10, and I've run out of spaces. Now, the general idea behind all of this is the fact that we have a greater than symbol living right there. Greater than symbol means two things. Thing number one is that it's a dashed line. That's why I made that picture look like that. So why don't I connect these best I can. Dash line, boom. Thing number two is this is greater than. And since this is greater than, that means you're going to shade above the line. So all of this is me shading above the curve, above the line. Now, this is an inequality. So what an inequality represents is any point in this shaded region is a solution to this inequality. If I plug in 0, 0 and do a little bit of math, I'm going to get a true statement because 0, 0 lives in the shaded region. If I plug in 6, negative 2 into this, do some math, I'm going to get a true statement. However, if I plug anything that's in the non-shaded region or anything on the line, it's going to be a false statement. So when you're graphing an inequality, you're finding all the possible solutions that if I were to plug that point into the original question, do a little bit of math, it's going to be true if it lives in the shaded region. That's how you do it. Let's factor a quadratic. This is a quadratic where the leading coefficient is invisible 1. So you're really looking at two numbers that add up to negative 7 and two numbers that multiply out to negative 18. Two numbers that multiply out to negative means one's going to be positive, one's going to be negative. So you think, all right, well, two numbers that multiply out to negative 18, one positive and one negative, but I need them to add to negative 7. How about negative 9 and positive 2? That works. Once you figure your numbers out, factoring looks like this. You make two parentheses. Since this is an x, you put x and x. And since you decided that those two numbers would be negative 9, you're going to make u negative 9 and u positive 2. Does it matter the order? No. I can make this x plus 2, x minus 9. What's important is the fact that I have this as negative 9 and positive 2. And if I were to FOIL this out to double check, I'm going to get that. Easy peasy. Let's factor a quadratic whose leading coefficient is positive invisible 1. Now when you do that, you're thinking of two numbers that add up to negative 9 and multiply out to positive 8. Now, if it's going to multiply out to a positive number and add up to a negative number, you're thinking of two negatives. Now, two negatives that multiply out to 8, let's try negative 4 and negative 2. Oh, that doesn't add up to negative 9. I guess that didn't work. How about negative 8 and negative 1? Gasp! That does add up to negative 9. So once you figure that out, factoring looks like this. You get two parentheses. You put an m there, you put an m there. One's negative 8. The other one's negative 1. Now, if you were to write this out as m minus 1, m minus 8, great. But either way is fine, and these are the numbers that you have to use. Factor this quadratic where the leading coefficient is not 1. Ugh. Well, whenever you're asked to factor, what you really want to try to do is see if there's a greatest common factor that you can rip out first. In this case, there isn't. So what we have to do is realize that we have possible combinations. Now, there is a process called MUT or MUDS or something. I don't know. I hate it. I don't use it. So don't do it. This is what I do. You write out all the possible combinations that you can to make 7. So 1 and 7. Easy peasy. You write out all the possible combinations that you can multiply out to make negative 20. Here's a hint. There's a lot of them. So negative 1 and 20. Negative 20 and 1. 20 and negative 1. 1 and negative 20. How about 10 and negative 2? Negative 10 and 2. 2 and negative 10. What else? Negative 2 and 10. How about 5s and 4s? How about negative 5 and 4, positive 5 and negative 4? How about negative 4 and 5, 4 and negative 5? Now what we're going to do is we're going to try to come up with a system where we multiply like we pick a number. We multiply the interior numbers, we multiply the exterior numbers, and we see which one of these adds up to negative 31. So maybe we take a guess, we take a stab, and we try U. I don't know if that's going to work. In fact, I'm pretty sure it won't. But what we do is we say, all right, 1 times 10 is 10. 7 times negative 2 is negative 14. That's not even close to adding up to negative 31, so a bad job by me. Why don't we try one of the ones that involve like a 35. So let's try to make one that's a 35 and a 4. So if I were to try this, that's a 35 and a 4. So multiply the insides, you get negative 4. Multiply the outsides, you get 35. So that's positive 31. So since that didn't work, this has got to be the one that will work. So multiply the insides. 1 and 4 is regular 4. 7 and negative 5 is negative 35. So since 1 times 4 is regular 4, and 7 times 5 is negative 35, that's going to give me the negative 31 that I need. That's the one that works. So yes, trial and error. So now that we have that, we make our parentheses. X and X. The numbers that attach to the X are 7 and 1 in that order. The numbers that are attached to the negative 20 are 4 and negative 5 in that order. So once you write out those numbers in that order, you should be able to look at that and say that 1x is useless. Let's rewrite it out and make it look prettier. 7x plus 4 times regular x minus 5. That's going to be my guy. When you FOIL that out in your head, you'll get 7x squared minus 35x plus 4x gives me that negative 31x that I need, and 4 times negative 5 is negative 20. The math teacher goat way of factoring quadratics where the leading coefficient is not 1. Factor 4x cubed plus 43x squared plus 30x. When you factor, that means one of two things. GCF, greatest common factor, see if you can rip out something that's in common with all of them. And then maybe if it's a quadratic, you could treat it like a quadratic. Well, that's not a quadratic. However, there's an x in common in all three of these, which means what I can do is pull that x out. That leaves me with 4x squared plus 43x plus 30. Now, what's left over is a quadratic. And this is one of those quadratics where the leading coefficient is not 1. So if you've seen me do this before, this is the Nick Parrish way of factoring quadratics where the leading coefficient is not 1. Not the prettiest thing in the world. But what I like to do is I list out all of my possible options that make 4, so 1 and 4, or 2 and 2. Those guys multiply out to 4. Then I list out all my possible options that multiply out to positive 30. So 1 and 30, 30 and 1. 15 and 2, 2 and 15. 3 and 10, 10 and 3, 6 and 5, 5 and 6, and I think I got all of them. Now what I do is I multiply insides, multiply outsides, add them together, and see which one adds up to 43. So some of this is guessed and test. So I want to pick one that's going to maybe multiply out to 43. So I like the idea of the 1, 4 and the 1, 3. That seems that it could possibly give me a 43. In fact, looking at it, I was wrong, but it's too late. I'm going with it. So let's test out to see what this would look like. Multiply the inside, so that's 4 times 1. Multiply the outside, so that's 30, so that gives you 34. So even though my numbers were correct, my heart wasn't. So I'm thinking, all right, well, if that didn't work, let's try the 1, 4, and let's do the one with the 10 and 3. So let's try a 10 and 3. And again, I'm just trying stuff out because of what I know with math. Let's multiply out this one and see if that guy works. Okay? So multiply the insides. 4 and 3 make 12. Multiply the outsides. 1 and 10 make 10. So that's not my 32. So I probably should have selected this guy instead. Multiply the insides. 4 and 10 make 40. Multiply the outsides. 1 and 3 make 3. And that gets me 43. That's my guy. So the inside quadratic is going to have x's. Since I chose to go with the 1 and 4, you're going to be 1, you're going to be 4, in that order. Those are the numbers attached to the x. The numbers that are attached to nothing in that order are going to be 10 and 3. So you're plus 10, and you're plus 3. That x is still there. Story of my life. So you have x plus 10, because I'm getting rid of that 1. You have 4x plus 3. And that's how you factor that monstrosity. And it is a monstrosity. It's not fun at all. Solve n squared plus 4 equals 40. Well, we need to get n all by itself. There's a squared and there's a 4 floating around. Let's get rid of that 4 by subtracting him from both sides. Him or her from both sides. Pardon me for, I didn't mean to assume. N squared is now going to equal 36. Now, in order to get n all by itself, you have to undo a square. The way you undo a square is you square root both sides. Now, this is extremely important. What that does is the square and the square root cancel each other out. Whenever you square root both sides to solve, you have to attach the positive or negative symbol. So my answer is not going to be 6. My answer is going to be positive or negative 6. And the reason why is because if I were to plug in 6, square it, I get 36. 36 plus 4 is 40, hooray. But if I get negative 6 and square that, that's also 36, because when you square a negative, it becomes positive. So we have 2 possible answers, both positive and negative 6. Solve negative 10 minus 5n squared equals negative 330. Well, we have to get n all by itself. Negative 10 is floating around, negative 5 is attached. Let's add 10 to both sides. Let's add 10 to both sides, cross you out. Drop down the negative 5n squared, drop down the equals, and negative 330 plus 10 is negative 320. Now I have to divide both sides by negative 5. Divide both sides by negative 5. Cross you out. N squared equals negative 320 divided by negative 5 is 64. How nice. Because in order for me to get rid of that square, I have to square root both sides. Now what you do when you square root a square, you cancel each other out, drop down the n. When you solve an equation, and the way you solve that equation is you square root both sides, you have to attach a positive or negative onto the other side. So my answer is not going to be 8. My answer is going to be positive or negative 8. And if you're wondering why, well, if I went up here and plugged in 8 and do the math, I would be fine. But if I plugged in negative 8 and square that, you get the same exact number as if I plugged in positive 8 and squared it, because when you square a negative, it becomes positive. So I have 2 possible options, negative 8 and positive 8. Solve 9r squared minus 3 equals negative 152. I'm going to add 3 to both sides, like that. That gets me 9r squared equals negative 149. Now I'm going to divide both sides by 9. And unfortunately, the right side doesn't simplify. So yuckity yuck, gross, gross, gross. Now, I'm assuming we know about imaginary numbers at this stage, so this is what we need to do next. We need to square root both sides, square root both sides. Whenever you square root both sides to solve, don't forget to attach the positive or negative on the right side. R is going to equal, now there's a couple things going on here. We have the square root of a negative, which means we have an I involved, right? So I'm going to pull out that I. That leaves me with the square root of 149 over the square root of 9. When you take the square root of a fraction, you take the square root of the numerator and the denominator. So when all is said and done, I can't take the square root of 149. I can't even rip it apart. I don't even know what it's divisible by. So what I get is positive or negative. I is floating around. The square root of 149 lives in the numerator, and the denominator is the square root of 9, which is 3. So that is an awful looking answer, but you know what? It's an answer. Solve, parentheses, 3n minus 2, close parentheses, parentheses, 4n plus 1, close parentheses, equals 0. This is called the zero product property. The zero product property says that if I have A times B, so something times something equals 0, you set each of those things equal to 0. Because if A was 0, it cancels U out. If B is 0, it cancels U out. That's called the zero product property. The same rules are going to apply here. You're going to set 3n minus 2 equal to 0 and 4n plus 1 equal to 0 and solve each individually. So you're going to be plus 2, that happens, drop down the 3n equals 2, divide by 3, n is going to equal 2/3. Over here, you're going to follow a similar process, subtract 1, cross U out, 4n equals negative 1, divide by 4, n is going to equal negative 1 over 4. So I have two possible answers here. N equals 2/3 and also negative 1/4. Zero product property, very important. Solve 3k squared plus 72 equals 33k. Whenever we see something that looks like a quadratic and we're being asked to solve, we are thinking two things: factoring and zero product property. Now, in order for us to factor, I have to make sure everything is equal to 0. So that's the first thing I'm going to do. I'm going to subtract 33k from both sides and write things in appropriate order. Now I'm going to have 3k squared minus 33k plus 72 equals 0. Now that it's equal to 0, because again, I'm thinking zero product property thoughts, I'm going to factor. Now what I notice right off the bat is each term has a 3 in common. So factor out a 3, and that leaves me with k squared minus 11k plus, I thought it was going to be 21. It's actually 24. Oh, I got disappointed there. I was going to do the whole 21 thing, but it didn't work out. Very upsetting. Now I look at this, and I'm thinking, oh, I could probably factor that. That's a quadratic. So, since it is a quadratic, let's think of two numbers that add up to negative 11, multiply out to 24. Those two numbers would be negative 3 and negative 8. So k minus 3, k minus 8 equals 0. So now that I've factored, I can apply the zero product property. Now the zero product property says that if you have A times B or more equal to 0, you set each guy equal to 0, right? So A is 0, B is 0. The same rules apply here. Okay, 3 equals 0, which doesn't make sense. Let's get rid of that because 3 is not equal to 0. K minus 3 equals 0 and k minus 8 equals 0. Now it's a simple matter of you just solving. Add 3. K is 3, add 8, k is 8, and at the end of the day I have two answers, and those two answers are going to be k equals 3 and k equals 8. And that's how you do it. Fun stuff. Solve, holy cow, negative 2v squared minus v plus 12 equals negative 3v squared plus 6v. Well, when I see a quadratic, and yes, this is a quadratic equation, and I'm asked to solve, I'm thinking a couple things. First off, I want to set everything equal to 0. Once I do that, I want to factor things out. And once I factor things out, I want to use the zero product property. Okay, so let's get everything equal to 0 first. Let's move everything from the right to the left. So add 3v squared, add 3v squared to both sides. While I'm at it, let's subtract 6v, subtract 6v. That gets rid of everything on the right and gives us the 0 that we want. Negative 2v squared plus 3v squared is just 1 invisible 1v squared. Negative v minus 6v is negative 7v. And then plus 12 is just lingering. And this is all crooked, so I'm going to leave it. And actually, no, I'm going to erase it. I'm going to erase it, make it look pretty. All right. So now that I have everything equal to 0, which I do, let's factor. So what you do when you factor is you think of two numbers that add up to negative 7 and multiply out to 12. So if it multiplies out to a positive but adds up to a negative, you have two negatives living in here. So v minus something and v minus something. Two numbers that multiply out to a 12 but add up to a 7 are going to be 3 and 4 in no particular order. Now that I have it factored, I'm going to apply the zero product property. The zero product property says that if I have something times something equals 0, you set each something equal to 0, right? So v minus 3 equals 0, v minus 4 equals 0. Then you solve each one. Add 3 to both sides, v equals 3. Add 4 to both sides, v equals 4. And we have two potential answers, 3 and 4. And that's how you do it. Solve by completing the square. Now, in order to do completing the square, the first thing you need to do is make sure that everything that is a squared or a regular variable is on the left and everything that's not is on the right. So I have to get rid of this negative 91 by adding 91 to both sides. Cross U out. So now I have just the quadratic term, and the linear term is going to equal 7 plus 91, which is 98. Okay, that's one short of how many problems JC has. Now, make sure there's nothing in front of r squared. Since there's nothing in front of r squared, I can proceed. What you do is you take half of the number in front of r, which is negative 2. You square that, which is 4. And you add that to both sides. So you're going to add 4 to both sides. Okay, so r squared minus 4r plus 4 is equal to 102. Now that you have this on the left, this is a perfect square trinomial. That's what's going to happen every single time that you do this. You will be able to factor this as a perfect square trinomial. So, since this was negative 2, that means this ended up being r minus 2 squared equals 102. Now, I have to solve for r. In order to solve for r, what we do is we square root both sides to get rid of the square term. So square root both sides. Remember, when you solve and square root at the same time, you attach a positive or negative. So what we have up here now is we have r minus 2, because when you square the square root or square root the square, they cancel each other out. So r minus 2 is alone, equals positive or negative 102. You can't do much of the 102, so I'm not going to try to make a factor tree and simplify that. But in order to get r by itself, what I have to do is add 2 to both sides, add 2 to both sides, and r is going to equal, let's move it this way, 2 plus or minus the square root of 102. Okay? That's completing the square. Not the easiest process in the world, but not the worst either. Solve by completing the square. In order to solve by completing the square, what I have to make sure is make sure that my regular number is on the right side and my variables are on the left. So I have to kill two birds with one stone here. I'm going to subtract 79 from both sides, and I'm going to add 18n from both sides. Okay, that crosses you, and that leaves me with 9n squared plus 18n equals negative 79. This is not going to be pleasant at all, because the next step is to make sure I have nothing in front of n squared. So in order to get rid of the number in front of n squared, I divide everything by 9. Everything by 9. You cross out, become n squared. You become 2n, which makes life easy, but you are negative 79 over 9. Gross, grossy, gross, gross, gross. Now the next step in completing the square is you take half of the number in front of n, which is 1, you square that, which is 1, and add that to both sides. So let's move it up here. What we get on the left is now n squared plus 2n plus 1. These guys are supposed to add, so why don't I turn 1 into 9 over 9? So I'm going to say equals 79 over 9 plus 9 over 9. The right side's going to simplify out to negative 70 over 9. Still not that pleasant. Okay, now the left side is a perfect square trinomial. It's always going to factor out to a perfect square, like that. That's why it's called completing the square. What we do now is we need to get rid of that squared, and we do so by square rooting both sides. Don't forget to attach your positive or negative. N plus 1 on the left is going to equal positive or negative 70 over 9 inside the square root. Now, a couple things that I can do inside this square root. Since it's a negative, I can pull out an I. Now I can write this out as the square root of 70 over the square root of 9. Square root of 9 is 3. So I have positive or negative I square root of 70 over 3. And that's going to equal n plus 1. Now I'm not quite done yet because n is not all by itself. So we subtract 1 from both sides, and our final answer is going to be negative 1 plus or minus I square root of 70 all over 3. Horrifying, but that's how you do it. Solve by completing the square. In order to solve by completing the square, what you want to do first is make sure the constant that's lingering on the left is now on the right. So let's subtract 67 from both sides. That leaves us with 2x squared minus 5x equals negative 67. The second thing I want to do is I want to get rid of the number in front of x squared. So divide everything by 2. So that leaves us with x squared minus 5 over 2x equals negative 67 over 2. Awful. Now the next thing that we're going to do is we're going to take half of the number in front of x, which is going to be half of negative 5 over 2. When you multiply negative 5 over 2 by a half, you get negative 5 over 4. You take that number, you square it, and you add that to both sides. So negative 5 over 4 times negative 5 over 4 is positive 25 over 16. You're going to add that to both sides, positive 25 over 16. Okay, so if you're looking at this and saying, this is going to be bad, yes, this is going to be bad. Now the left side is a perfect square trinomial, which means it's factorable. And you might look at that and say, how in the world am I going to factor that out? Well, the number that you use when you factor it out is half of the number in front of x. So this part's actually not super bad, like the movie, and you end up with x minus 5 over 4. So that part's okay. The parts that's not okay is this guy over here. I need to multiply u by 8 over 8 in order for me to combine these terms. So negative 67 divided by 8, multiplied to 8 is 536. So you become negative 536 over 8 plus 25 over 8. All right, so I'm going to still keep you written as x minus 5 over 4 squared equals negative 536 plus 25 is going to be negative 511. Ugh. All right. Now, in order to get rid of the square, I have to square root both sides. So let's square root both sides, square root both sides. Don't forget to attach the positive or negative. That allows this guy to be eliminated. X minus, like you guys cross out, x minus 5 over 4 equals, now there's a lot going on here, positive or negative, negative 511. So at the very least, what I can do is pull out an I. Square root of 511, I don't think there's anything you can do with that. Okay, I don't think so. I don't think you can make a factor. In fact, I'm not even going to bother. I'm just going to leave it. This becomes the square root of 8, though. Okay, the square root of 8 is also the same as the square root of 2 over root 2. So you are the same as plus or minus square root of 511 over 2 root 2. Multiply the top and the bottom by 2 or by root 2. That leaves me with x minus 5 over 4 equals positive or negative the square root, oh, don't forget the I, the square root of 1022 divided by 4. Ugh. Now the square root of 102, or I'm sorry, 1022, you can't do anything with. You can't. I just paused the video and checked. So we're stuck here. But the way we're going to end this problem is we're going to add 5 over 4 to both sides. And our answer is going to look like this. X equals 5 over 4 plus or minus I times the square root of 1022 over 4. Completing the square is a nightmare at times. I'm not a fan of it. So the next few videos are about the quadratic formula, which is so much nicer. Solve using the quadratic formula. In order to use the quadratic formula, what you need to do is you need to make sure that everything is equal to 0. So let's subtract 18. Let's subtract 18. And that leaves us with 8n squared minus 4n minus 18 equals 0. Once you have it equal to 0, label the number in front of n squared a, label the number in front of n b, and label the number that's floating around c. Now the quadratic formula is x equals, but this is going to be n equals, and let's sing a song. N equals negative b plus or minus square root of b squared minus 4ac all over 2a. You're welcome. Now, normally it's x equals, but this is n because we were given n. So let's plug stuff in. N equals negative 4 plus or minus the square root of negative 4 squared minus 4 times a, which is 8, times c, which is negative 18, all over 2 times 8. All right, so let's do a few things. Negative 4 is positive 4, plus or minus the square root. 4 squared is 16. Well, negative 4 squared is 16. Either way, 16. 4 times 8 times 18 is 576. So, that, by the way, negative, positive 576. All over 2 times 8, which is 16 again. Okay, 4 plus or minus, you can combine these to get 592. Now the prime factorization is 592 is this. Okay, if you were to make a factor tree out of this, you would get 2 times 2 times 2 times 2 times, what was the other? 37. All over 16. Whenever you take the square root, you pull out groups of 2. So I'm going to pull out 1, 2, and pull out another 2. And that leaves me with 4 plus or minus 2 times 2, which is 4, square root of 37. That's going to be all over 16. Now I notice, oh, I can factor out a 4 out of both of these. So factor out a 4, 1 plus square root of 37 is going to be left over. I can factor a 4 out of 16. These cross out, and our final answer is going to be 1 plus or minus the square root of 37 over 4. Quadratic formula, baby. Solve using the quadratic formula. In order to use the quadratic formula, we need everything on the left and 0 on the right. So let's subtract x from both sides, and that gets me 10x squared minus invisible 1x plus 9 equals 0. And now you might be thinking, whoa, 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 with the invisible 1. The next step is to label the number in front of x squared a, the number in front of regular x b, so yes, negative 1, and 9 c. And then you whip out the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, you're welcome. X equals negative 1, so double negative, plus or minus the square root of b, which is negative 1 again, squared minus 4 times 10 times 9, all over 2 times 10. 1 plus or minus the square root of 1 squared, which is 1, minus 4 times 10 times 9 is going to be 900? No, 360. Boy, was I way off. So minus 360. Ooh, we're going to get a negative. That's going to be over 20. So when I do the 1 minus 360, that's 1 plus or minus the square root of negative 359, all over 20. Now, you can't prime factorize, I don't know. You can't make a factor tree and do anything special with that, so I'm leaving that like that. However, that negative square root means I can whip out an I. So I have 1 plus or minus I times the square root of 359 over 20. And that's how you do it. Solve using the quadratic formula. We have 4x squared plus 4x minus 8 equals 1. In order to use the quadratic formula, you need to get rid of everything on the right side and have it equal 0, so let's subtract 1 from both sides. When you do that, you're left with 4x squared plus 4x minus 9 equals 0. Label the number in front of x squared a, label the number in front of x b, and label the number floating around c. Then we're going to whip out the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So x equals negative 4 plus or minus the square root of 4 squared minus 4 times negative 9 all over 2 times 4. Okay, that's going to be 4 plus or minus 4 squared is 16, minus 4 times 4 is 16 times negative 9, which is 144. Oh, that's nice. I mean, it's not going to help us, but that's nice. It's actually not going to help us at all. All over 8. Now, inside that square root, we can do a little bit of math. So negative 4 plus or minus the square root of, what is that, 160? Yeah, look at that. All over 8. Now, 160 is the same thing as 16 times 10, all over 8. The square root of 16 is 4. So this simplifies out to negative 4 plus or minus 4 times the square root of 10 all over 8. And at this stage, you should notice, wait a minute. 4, 4, 8, I can factor a 4 out of literally every term here. I can factor a 4 out of the top, which is going to leave me with negative 1 plus invisible 1 square root of 10, all over factor a 4 out of 8, so that's going to be 4 times 2. The 4's cancel out, and my final answer is going to be x equals negative 1 plus or minus the square root of 10 all over 2. And that's how you do it. Find the value of the discriminant. The discriminant is you labeling the number in front of m squared a, the number in front of m b, and the number floating around c. The discriminant is b squared minus 4ac. So if you're thinking, wait a minute, that's the quadratic formula. That's the part underneath the square root. You're absolutely right. But right now I'm just finding a number. So b squared is going to be negative 4 squared minus 4 times a, which is negative 4, times c, which is 5. That becomes 16 minus negative 4, so that's 16 again, so plus 16 times 5, which is 80. So plus 80, which ends up being 96. A positive discriminant. I wonder what that means. Find the value of the discriminant to determine the number of real and imaginary numbers. Okay, so discriminant is basically you have to set everything equal to 0. So let's subtract 8a and 4, or add 4 to both sides. So let's subtract 8a, add 4 to both sides. That'll cancel out the entire right side. 4a squared minus 8a plus 4 equals 0. Okay, you label, so treat this like quadratic formula. Label you A, label you B, label you C. The discriminant is b squared minus 4ac. That's the part underneath the square root of the quadratic formula. So you're going to do negative 8 squared minus 4 times 4 times 4. Lots of 4s. It's like we're playing golf. Anyway, negative 8 squared is 64. Negative 4 times 4 times 4 is also 64, which gives us 0. Now, when the discriminant is positive, you get two real numbers. Because if we were to do the quadratic formula, we would get a positive square root, which means it's a real number. If it was negative, we would get two imaginary numbers. Okay, because if the square root is negative, we don't have anything positive. In this case, this is 0. When it's 0, we get one real number. And that real number is technically used twice. It's called a double root. But that's how you do this problem. You get one real number when the discriminant is 0. That's how you do it. Find the value of the discriminant to determine the number of real and imaginary solutions. So I need to first get rid of everything, subtract 10x, subtract 5, subtract 10x, subtract 5, and treat this as if I'm doing the quadratic formula. 2x squared minus 10x minus 5 equals 0. Okay, let's label u A, let's label u B, and let's label u C. Now the discriminant is b squared minus 4ac. Yes, that's the part underneath the square root in the quadratic formula. So we're going to do negative 10 squared minus 4 times a, which is 2, times c, which is negative 5. This gives me 100. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is positive 20. No, it's not. 40. Silly me. And that number is 140. When your discriminant is positive, that means when you take the quadratic formula and do all that stuff, you get a positive number underneath the square root, which means no i's. So when you do that, you're going to get positive or negative, which means two possible real solutions. So whenever your discriminant is positive, you get two real solutions. When it's negative, that's where you come up with the i's. That's two imaginary solutions. And when it is equal to 0, like in a previous problem I did, you get one real solution. Well, this is two real solutions for the reasons I just explained. And that's how you do it.